be different. I mean, what you said is absolutely right. Yeah. Okay. So that'd be one way of saying it. This marginal labor, the marginal product of labor and capital are different between the two industries. So what it turns out to be is that the substitution possibilities in the machinery industry are likely to be different than the substitution possibilities in the clothing industry. And in fact, what would we think? Machinery is capital intensive, so as wage gets more and more expensive, we might expect that the capital to labor ratio would rise more quickly, which is what we would mean by a flatter curve. The clothing industry is still labor intensive, so even though workers are more expensive now, we still need workers. There's less of a substitution possibility here than there is in the machinery industry. Again, we don't always have all of that information, but in general, this is what we would see. The capital intensive industry would be further to the right and have a somewhat flatter slope than what the clothing industry would be. Okay, so notice then that what we see here. If we had a relatively high relative wage, the capital to labor ratio in the machinery industry is going to be much greater than the capital to labor ratio in the clothing industry. And if, for some reason, the relative wage were to fall, capital becomes more expensive relative to labor, notice that the capital to labor ratio falls in both industries. Okay. In both industries. Now that's interesting if you think about it. Capital to labor ratios are falling, but we have a fixed amount of capital and a fixed amount of labor. We're fully utilizing all of our capital and all of our labor, but we're changing the ratios at which we're using them within the industry. So one of the things, the next thing that we need to look at then, this is kind of half of what we need, is what is the relationship between the factor prices and the goods prices? Okay, the factor prices here are the wage to rental ratio, and the goods prices is the price of machinery compared to the price of clothing. Okay. So what is this relationship? That's what we want to look at now. Okay. It turns out that there is in fact a positive relationship, as you might expect. Oh, okay. I'm sorry, I switched this around. So let's look at the relative wage to the relative price of clothing. Relative price of clothing. Remember, clothing is labor intensive. Now, let's just think for a minute if there were no possibility for factor substitution. No possibility for factor substitution. In other words, as wage rates went up, you still had to employ the same amount of labor and the same amount of capital. So whatever the labor and capital are that you were using in the clothing industry, wages would go up, so now your cost of labor would go up proportionally. Can't make any substitution effects. Which means that as labor becomes more and more expensive, you have to raise the relative price of clothing. The price of clothing's got to go up. Increase the cost, you've got to increase the price. However, there are substitution possibilities. So as wage rates go up, labor becomes more expensive. We know that's going to lead to higher prices for clothing. But we also know that clothing manufacturers are now going to start using more capital in less labor. So that means that their prices of clothing shouldn't have to rise proportionally with the increase in wages. Right? So let me just say that again. If wages are rising, now the cost of producing clothing has increased, so clothing prices have to rise as well. But if producers have the ability to substitute out of more expensive labor and into less expensive capital equipment, then that means that clothing prices will rise more slowly than the wages will themselves. So that gives us then a less than proportional change. Yeah. Yeah, let me draw the diagram first, and then maybe it will be a little clearer. Okay, so here, it's important to recognize what we have on the axes here. So this is the relative price of cloth, or clothing, and here's the wage rate. Now let's assume that there were no substitution possibilities at all, right? You have to use fixed amounts of capital and labor. If that were the case, then as wage rates went up, we would also see that the price of cloth had to increase proportionally. So no factor substitution. So what we've done here is we've had an increase in the wage rate with R constant. So basically it simply says as the wage rate goes up, the cost of clothing will go up proportionally. But if we have substitution possibilities, we can still make additional cloth, or we can make cloth with fewer workers. So what it really suggests is that this relationship looks more like that. Okay? So again, trying to remember what I said just a few minutes ago. If we increase the price of labor, producers will try to minimize the use of labor by substituting relatively less expensive capital, so that the price of clothing, even though it's labor intensive, will not rise as quickly as wage rates rise themselves. Okay? So again, we've got a proportional increase if there's no factor substitution, but if we have factor substitution, there's probably something that's very close to proportional at low wage rates, but as wage rates get higher and higher and higher, you're going to make greater and greater efforts to substitute out. I'm sorry? Oh, probably not. The straight line probably should have been steeper. Uh-huh. Now, all the workers from here down are dead because they can't live on that wage. No, no. It's just poorly drawn. The red line should actually probably be steeper here. Ah, thank you for asking. So, SS stands for Stolper-Samuelson. This is known as the Stolper-Samuelson equation. After Stolper and Samuelson, who were the first ones to actually discuss this in any sort of analytical detail. So it's called the SS curve because both their names begin with S. Yes? Yes. Okay, so let me redraw the red line since that's confusing to many people. Okay, so again, the key here is just to recognize what this relationship looks like. It is not a proportional relationship, but it's a relationship that simply shows that relative prices will rise more slowly than relative factor returns because we have substitution possibilities. If we didn't have substitution possibilities, this wouldn't work. But because we can substitute out of the factor that is becoming more expensive, we now have a relationship that is no longer proportional. Okay? Now, we're going to take this diagram and we're going to rotate it. Okay? So we're going to rotate it minus 90 degrees. So this is going to become our vertical axis. This is actually going to become our left horizontal axis. And what we end up with is a diagram that looks something like this. Now notice the information that we have here. Relative wage rate and our capital to labor ratio. So that shows us our substitution possibilities. And over here, we have the relative wage rate on the vertical axis, and on the left horizontal axis, the relative price of cloth. Now again, in setting this particular model up, it's very important to make sure that you have the right variables in the right place. So let me just highlight those. Price of cloth is labor intensive. Numerator, numerator, labor intensive, denominator. So you always want to make sure that you've got those axes set up correctly. Okay. Yeah.
So if we were talking about the price of machinery, would that be price of, like, it should be like PM over PC and
R over W and L over K. Right. So whatever good that you're focusing on, you want to always have in the numerator of your relative prices. That will then help determine what the ratio looks like in terms of the factor returns and the factor proportions, or the factor intensities. Now, here in this particular example, we're using labor and capital. It's actually possible to use two different kinds of labor. We could talk about skilled labor and unskilled labor, in which case we'd have wages of skilled labor versus wages of unskilled labor, or some measure of income inequality. So you just want to be careful. Whatever you put as the good that we're focusing on, in this case cloth, you just want to put the factor return that uses it intensely in the numerator of the vertical axis and in the denominator of the right horizontal axis. Well, we've seen all these axes, so we can fill in everything that's here. This was our cloth industry. This was our machinery industry. And this is our Stolper-Samuelson equation, or relationship. So notice what this tells us then. If this just happens to be our relative price for cloth, then knowing the relative price, the Stolper-Samuelson equation will tell us what our equilibrium relative factor returns are, the wage to rental rate ratio. Once we know that, our factor intensities or factor proportions lines will tell us what the capital to labor ratios are in each industry. Okay. This, by the way, is what is referred to as the Heckscher-Ohlin diagram. Which is kind of intriguing since Heckscher and Ohlin worked almost 100 years ago and the Stolper-Samuelson stuff was only done about 50 years ago. These things keep moving along. Okay. Now notice that in all of these diagrams that we have here in this Heckscher-Ohlin diagram layout, everything's in relative terms. We know the relative price of cloth, the relative wage rate, and the relative capital to labor ratios in both industries. What we don't know is the actual amount of capital or the actual amount of labor that's being used in each of the industries. And so we also want to find those actual amounts, not just the ratios. So we need to think now about how do we get to the actual levels that are being used. And to do that, we use something called the Edgeworth box. How many of you had Edgeworth boxes in micro? Oh, okay, so this will be fun for those of you who haven't had it. So in an Edgeworth box, we're going to start by looking at the machinery industry. So this is machinery. And what we have here is on the horizontal axis is our labor supply. And out here, this is the maximum labor in the economy. So we could go from no labor in machinery industry on the far left all the way out to everybody working in the machinery industry. On the vertical axis, we have the amount of capital that's being used in the machinery industry. And again, we can go from 0 up to the total amount of capital in the economy all being used in the machinery industry. Now, one of the things that we already know from our Heckscher-Ohlin diagram is what the ratio between these two are. So if we know the ratio, then we also can draw that should come out of the origin. we could also draw this ray. So this ray has a slope that's equal to the capital to labor ratio in the machinery industry. Okay? In other words, it's whatever this number is. That's what the slope of that ray is, that ratio. Okay? Now we can do the same thing for the clothing industry. Again, we've got nobody working in the clothing industry. We've got labor on the horizontal axis, the maximum, all workers in clothing. We've got capital on the vertical axis, all capital in the clothing industry. And remember that in the clothing industry, the capital to labor ratio was relatively low compared to what we saw in the machinery industry. So it's going to have a much flatter slope. So this is our CC. Okay, so remember the slopes of these rays are simply coming out of the Heckscher-Ohlin diagram, dependent upon the relative price of clothing in the relative wage rate. Now here we're going to do something, a little mathematical geometry trick. It's not a trick, it's just a technique. Notice that we've got labor on the horizontal axis. So as long as we're running left to right or right to left, we've still got the total amount of labor here. We're going to take this diagram and just flip it 180 degrees. And that then will give us a box called an Edgeworth box that looks like this. So notice the normal axes, this is still the 0 point for manufacturing, up to the total amount of capital being used in manufacturing, or the total amount of labor being used in manufacturing. I'm sorry, machinery. Or machinery now. So this is labor in machinery running in this direction. But also notice that up here we've got labor in clothing, but it's running in the opposite direction. So notice that if this is the amount of labor that we're using in machinery, we can go up to the top axis and figure out how much labor is being used in the clothing industry. It's whatever's not being used in machinery. Same thing with capital. This is on the left, we've got capital in the machinery industry, rising, and capital in clothing, falling. Okay? So again, all we've done is taken the clothing axis and flipped it completely around. So we can still put our rays in. This was manufacturing, and this was clothing. Afraid of that. And given the way that I've drawn it, we can see that we use very little labor in manufacturing and not very much capital either. We use a lot of labor in clothing, and we also use capital in clothing as well. Again, one of the things that you can see is the amount of capital that we use in manufacturing relative to the amount of labor is much bigger in machinery than it is in the clothing industry, even though many more workers and much more machinery is actually used in the clothing industry. Okay, is that clear to everyone? Yeah, so the thing to notice is that the capital to labor ratio in machinery is much greater than the capital to labor ratio in clothing. That falls out from our initial assumptions that machinery is capital intensive and clothing is labor intensive. But it's also true in the way we've set this up that there are more workers and more capital in the clothing industry than there are in the machinery industry. The actual amount of labor and capital in clothing is much greater than the actual amount of capital and labor in machinery. Not relatively, but absolutely. Okay. Now we can do some interesting things. So if we had started with an economy that we're making no particular assumptions about labor productivity or comparative advantage or anything else, we can now say, okay, this economy has a certain amount of capital and labor to start with. Now what we want to find out is what will happen to its production possibilities frontier if we increase one of the resources. Right? So remember, the whole goal here with the Heckscher-Ohlin model is trying to explain